Before we start our tutorial video today, if you love our videos, please click on like button and make sure to click on subscribe and bell icon to receive notifications of future helpful content of automation and process control. Now let's get started. Interface level measurement using pressure technology. Differential pressure transmitters are used to measure the interface of two fluids that have different specific gravities. To make an interface measurement, the overall level must be at or above the low pressure tap at all times. It is important that the level be large enough to create a reasonable dP between the two specific gravity extremes. This measurement can be done with or without remote seals. However, from a maintenance standpoint, it may be easier to use a remote seal assembly. Keeping the wet leg at a constant height can be difficult in some applications. Situation. A vessel requires an interface measurement where the level is 150 inches. The vessel has two fluids with specific gravities of 1.0 and 1.08. To determine the calibrated range for the transmitter, four assumptions need to be made. At the lower calibrated value, for milliamperes point, the tank is filled with the lighter fluid. At the upper calibrated value, 20 milliamperes point, the tank is filled with the heavier fluid. The taps leading to the transmitter are flooded at all times. The overall level should be equal to or higher than the upper, low pressure, tap. There is always a reference level seen by the low pressure side. This can be accomplished with either a remote seal system or a wet leg. The reference level must have a constant height and density. The calculation is modified slightly for wet leg systems when the density of the high and low pressure wet legs differ. Calculation of interface measurement. When the tank is filled with the lighter fluid, the transmitter will be at 4 milliamperes, or 0% of span, and L2 equals L. So high pressure side equals L2 multiplied by S2 plus D multiplied by SF. The result will be 196.7 inch H2O. Low pressure side equals D multiplied by SF plus H multiplied by SF. The result will be 186.8 inch H2O. At 4 milliamperes dP range equals HP minus LP, so the result will be 9.9 inch H2O. When the tank is filled with the heavier fluid, the transmitter will be at 20 milliamperes, or 100% of span, and L1 equals L. So high pressure side equals L1 multiplied by S1 plus D multiplied by SF. The result will be 208.7 inch H2O. Low pressure equals D multiplied by SF plus H multiplied by SF. The result will be 186.8 inch H2O. At 20 milliamperes dP range equals HP minus LP, so the result will be 21.9 inch H2O. The calibrated span is 9.9 to 21.9 inch H2O. When the transmitter reads 9.9 inch H2O, the tank is filled with the lighter fluid. When the transmitter reads 21.9 inch H2O, the tank is filled with the heavier fluid. To determine where the interface of a mixture of fluids is, use the dP reading as a percent of span. For example, if the transmitter output is 18.4 milliamperes or a dP of 20.7 inch H2O, the interface is calculated by using the formula. Let's see this graphically. At 4 milliamperes, tank is filled with lighter fluid. At 20 milliamperes, tank is filled with heavier fluid. At 18.4 milliamperes, tank is partially filled with heavier fluid and partially filled with lighter fluid. Finally, this application example is based on the technical data sheet of interface measurement using pressure technology issued by Rosemount. Also, you may refer to my previous tutorial videos about how we can calculate the dP transmitter range for an open and closed tanks, as I left the link of each video in the description box below. Thank you so much for watching and have a nice day.